On today's episode we are doing a full play-by-play analysis of Starship's maiden voyage into oblivion from the moment of ignition to the explosive finale and the aftermath that followed. We are breaking down everything that happened to the Starship, what it all means, and how SpaceX will forge a path to future success with this launch system. This is everything you need to know about the flight of the most powerful rocket ever created. This is the space race on April 20th at 9:33 a.m. Eastern Time. The moment we've all been waiting for arrived. A fully stacked and fueled Starship ignited its super heavy booster and lifted off into the morning skies above Boca Chica, Texas. Starship flew for 4 minutes, reaching an altitude of about 39 kilometers and a maximum speed of 2,150 kilometers per hour. Unfortunately, Lee at T+4 minutes after the loss of vector control, which resulted in some interesting acrobatics, the flight termination system activated and Starship was completely destroyed. Over the Gulf of Mexico now, as most rocketry enthusiasts and industry experts will tell you, a successful first test flight is anything that succeeds in lifting off the pad. So in that regard, Starship's first launch was pretty normal aside from the SLS, which got its payload all the way to the moon on the first try. Most recent examples of first flights and test runs of new rockets like Relativity's Terran 1 and the same way as this attempt did with a failure to reach outer space. That being said, almost immediately after ignition started, it was clear that there were some big problems for Starship. The large cloud of dust and smoke forming around the rocket while it throttled up on the orbital launch mount looked normal at first but soon started throwing out large chunks of concrete debris, indicating that the launch pad was getting badly chewed up by the massively powerful Raptor V2 engine array. Once the clamps released, Starship tilted on a slight angle and slid sideways in what was likely a launch pad avoidance maneuver, a common practice that tries to save launch architecture any extra damage from the liftoff thrust by getting the rocket exhaust pointing somewhere else. But as the booster cleared the Mechazilla tower, we could already see that 3 engines had not lit. In this camera angle from SpaceX, we can see both the angular liftoff trajectory and the shower of debris splashing down into the ocean, but it was still flying thanks mostly to the fact that Starship doesn't actually need all 33 engines to fly, especially when it's carrying no payload. As the flight continued, though, we started seeing more signs of trouble. More engines began failing, and at about T+30 seconds we can clearly see some explosions from just above the engine housings that rain debris off the side of the rocket. Observers are pretty sure what we're seeing here is the destruction of the hydraulic power units, the equipment that generates the pressure used for gimbaling the main engines. That's when the engine nozzles change their angle to help steer the rocket. The hydraulic system is also responsible for unlatching the second stage. The hydraulic failure theory is supported by the slow loss of control that begins shortly afterwards. That, coupled with 2 more engine failures, we can assume that each engine loss is roughly 9% of the total thrust. So the loss of these engines and the pus not only account for the eventual loss of control suffered by the giant rocket, but it also accounts for the late arrival to max Q, the point at which the vehicle is under the highest mechanical stress due to its speed and environmental resistance. By this point the vehicle can't keep its nose up and the aerodynamic stress is becoming extreme. We've lost as many as 8 Raptor engines, and there is plenty of visible sputtering and flaring from the super heavy thrust section. As the rocket continues trying to right itself, it starts going through loops, and while this is obviously not supposed to happen, it's hard not to be impressed that Starship is able to keep its integrity through not 1 or 2 loops but nearly 4 full rotations. As it falls, Starship even hit a second max Q event on the way down before it exploded. It's really hard to understate how well the fuselage held up in this particular moment. Most rockets break apart if they turn even slightly out of alignment during a launch, and that's not because they are poorly made, it's because they're incredibly massive objects traveling at supersonic speeds that high up. The first stage booster is almost out of fuel tool, and the second stage becomes much heavier. Aerodynamics is pulling one way while gravity and inertia are pulling in other directions. Nothing is able to hold up under those sorts of strains, and we even see the exact moment Starship also loses this battle. This is a shot which reportedly comes from a flap camera just before the flight termination system activated. What you're seeing is the first stage booster bending at a pretty severe angle. Let's also quickly note that we can see 3 of 4 instances of missing heat shield tiles on the ship from this angle, which is really good considering the circumstances. If this is genuine, then it is definitely what caused the FTS to finally kick in. The booster is moments away from crumpling and separating all on its own, but even though this proves that Starship is an incredibly tough vehicle and that it has more than enough power to get into orbit, the damage caused by those Raptor V2 engines is a gigantic issue. These are images of the launch site 2 days later courtesy of Y+ on YouTube. Huge chunks of reinforced fond egg concrete litter a wide area around the Mechazilla tower, but these are just the bits that didn't hit anything. Take a look at the orbital tank farm. That new protective berm wasn't nearly tall enough to stop whatever force or debris crumpled those fuel tanks. The Mechazilla tower itself seems to have weathered the launch relatively well, but surrounding architecture, like the Drawworks building where the sensitive lift mechanisms for the tower's arms are kept, looks like these shelled leftovers of a World War II bunker. Damage to the inside of the door here makes it pretty clear that there will need to be repairs made to that lift equipment. Getting closer to the heart of the blast, the orbital launch mount has been pretty thoroughly chewed up. It doesn't look very different from the damage the SLS did to the mobile launch platform in November 20th, 22. Most of the Plumbing and shielding looks rough but not beyond repair if SpaceX wasn't going to be forced to take the whole thing apart. That is because here we see the worst of the damage. The concrete pad, or what's left of it, that new heat-resistant fondag didn't stand a chance. Just look at that hole. We can infer here that the flame from the engines burned straight through the concrete pad and allowed the hot gas to get under the ground and build up pressure until it exploded out through the path of least resistance, taking half of the launch mount's foundation along with it. Here we can see the biggest actual problem with the Starship launch. Losing a test vehicle is normal. Losing your launch architecture because of some botched maths is not. According to Elon Musk, the SpaceX engineers have been working on a better option for the pad under the launch mount, but it wasn't ready in time for the first test flight. This is going to become a point of debate over the weeks and months to come. If SpaceX had waited, they very likely would have had a more successful test flight with much less infrastructure damage. But going by the data from their static fire on February 9th, the team at Boca Chica thought that the new high-strength and heat-resistant fondag concrete they had recently installed under the Olm would be able to take the pressure from a single test launch. After all, it had held up remarkably well after that static fire, but that was with the engines at just under 50% thrust, and while there is a water sprinkler system in the launch mount, the pad at Boca Chica is not equipped with flame diverters or a full water deluge like a typical NASA pad, so there's nowhere for that energy to go but into the pad. Concrete hardens in a crystalline pattern. Once a single crack forms, the whole structure can fail catastrophically. You can even see in the pictures that the rebar supporting the concrete is still in place, which means that the pressure from the engines found a way into the pad itself and blew the concrete apart. So how does SpaceX get back on their feet here? Elon says that the company will be able to launch again in 1 or 2 months, but there's just no way that's a possibility if the only thing they had to do was fill in the crater under the Olm, replace the tank farm equipment, and repair the launch apparatus. Maybe that could be done in 2 months, but the fondag obviously can't take the strain, and it's likely the reason this test launch didn't end well. Remember the cloud of debris during ignition? It's a possibility that the 3 dead engines at the beginning failed to light, but it's much more likely that debris got shot up into the engine cavity while Starship was still clamped down, causing not only those first engines to cut out, but also the damage to the hydraulic power units and the later engine failures as well. If we go back to that Drawworks cover on the launch tower that was turned into Swiss cheese, imagine anywhere near that amount of damage hitting the thrust section of the booster. It could have just been torn up by the time the rocket was in the air. You can even see from some of the images that the cold engines didn't just refuse to light, they lost their entire engine bell. That's either directly from debris impact or the full force of 33 Raptor V engines reflecting off the pad caused more stress than the engineers had planned for. So if they are going to have a successful test, SpaceX will need to finish that other launch pad solution. Elon mentioned that the SpaceX engineers we're working on a water-cooled steel plate to go under the launch mount. Steel definitely takes heat better than concrete does, but it deforms easily. In order for just a steel plate to work for Starship's output of heat and force, it would have to be truly massive, and having a blade of coating a couple feet thick to absorb some of the initial heat. That is according to Dr. Phil Metzger, co-founder of NASA KSC Swamp Works. Dr. Metzger and his team experiment with launch solutions all the time, and he believes the steel plate idea can work because he's used it with his own experiments in the past. More specifically, he says that the water-cooled idea is what makes this a realistic solution. The plate wouldn't have to be nearly as big or have quite so thick an ablative layer. It could also work with a dilution system using a constant flow of water to dampen noise, engine force, and heat. After solving the launch pad issue, the other physical problems are much more achievable. The hydraulic power unit exploding is already a thing SpaceX won't have to deal with in the final version of their rocket, since they've begun using electric thrust vectoring for their newer vehicles, but mechanical issues are easy compared to the potential problem SpaceX now faces with the FAA because there's some damage we didn't cover earlier. Residents in Port Isabel, Texas, 6 miles north of Starbase, reported broken windows, a rain of fine particulates just after the launch, and that doesn't seem like a lot, and certainly no one was hurt, but this is the sort of thing that FAA pays attention to. It doesn't matter that this probably only happened because Starship had to activate its flight termination system. The FAA exists to keep the public safe from potential accidents, and they will require a list of safety changes before allowing SpaceX to fly a Starship again. That being said, SpaceX has gotten used to the FAA taking their time with giving them certification, so I'd imagine this isn't too high on their list of worries at the moment. The flight team has mountains of useful data they need to go over and share with the design team, which could mean some redesigns to the rocket, and it's going to take some time to repair all the damage and make the necessary upgrades to the launch area more realistically. This work could take a couple of months or even a year, but it's work that needs to be done because there's no way the FAA or NASA is letting them dig a crater like that at Pad 39A. So if Starship is ever going to the moon, then it needs to clean its act up and quickly. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it, that really helps us out for real, and subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week, and if you'd like more, we've got 2 more on the screen for you right now.